Howdy, welcome to my Capstone defense on geoengineering, vital research on global efforts to manage the growing risks from climate change. Glacial geoengineering is the deliberate modification of the climate system around a glacier to retard the melting of the ice shelf and reduce sea level rise. The Thwaites Glacier of West Antarctica is known as the Doomsday Glacier. A proposal towards glacial geoengineering would be to artificially pin the glacier in its current position by building a massive earthen berm on the sea floor. The giant mound, made from about 1.5 cubic miles of dredged material, would block the flow of warm water, melting the ice from underneath. Other techniques for glacial restraint include draining or freezing the bed, altering surface albedo, creating obstacles restraining snow, stiffening shear margins with ice, blocking warm sea water entry, thickening ice shelves, increasing buttressing, and strengthening fractured shelves against disintegration, as well as using regional climate engineering or local cloud seeding to cool the glacier or add snow. There are two broad categories for geoengineering. The first is carbon dioxide removal, CDR. Carbon dioxide removal refers to approaches that remove carbon dioxide, CO2, from the atmosphere. CDR encompasses a wide array of approaches, including direct air capture, DAC, coupled to durable storage, soil carbon sequestration, biomass carbon removal and storage, enhanced mineralization, and afforestation or reforestation. Abiotic approaches harness the physical or chemical properties of the ocean to remove CO2 from the air. Some examples are electrochemical techniques, artificial downwelling, and alkalinity enhancements. Biotic approaches include ecosystem restoration, which can provide carbon removal. Some examples are seaweed cultivation, artificial upwelling, and coastal wetland restoration. The second broad category for geoengineering is solar radiation modification, SRM, also known as solar geoengineering. SRM is a deliberate and large-scale intervention in the Earth's climatic system in order to address a symptom of climate change by reflecting more sunlight back into space or by allowing more infrared radiation from Earth to escape in order to reduce the Earth's temperature. Another method of carbon dioxide removal is bioenergy with carbon capture and storage. BECCS entails burning biomass for energy, capturing the CO2 emissions, storing the emissions long term, and successfully regrowing any used biomass. The notion of artificially cooling the climate emerged in the 1960s, concurrently with the potential risks of climate change. SRM technology options include stratospheric aerosol intervention, SAI, marine cloud brightening, MCB, cirrus cloud thinning, CCT, and ocean albedo change, OAC. The term geoengineering has been around since the 1970s. In the early 1970s, it was coined by Cesar Marchetti. There are several definitions of geoengineering at the global and domestic level. The Convention on Biological Diversity (CBD) defines geoengineering as any technologies that deliberately reduce solar insolation or increase carbon sequestration from the atmosphere on a large scale that may affect biodiversity. After the publication of the 1992 United States of America National Academy of Science assessment on global warming, the term became mainstream. CDR techniques are the most politically acceptable and have the least amount of controversy. SRM employs mechanisms to reflect the sun radiation back into the atmosphere. SRM techniques ensure that the Earth absorbs less solar radiation. Coastal wetland restoration is the first method of CDR we will discuss. A wetland is an area of land that is saturated with water and characterized by plants that can tolerate wet soils and low oxygen levels at their roots. Coastal wetlands include saltwater and freshwater wetlands located within coastal watersheds. Coastal wetlands serve as storm surge protectors when hurricanes or tropical storms come ashore. Wetlands can play a role in reducing the frequency and intensity of floods by acting as natural buffers. Here is a map of the extent of coastal watersheds in the conterminous U.S. Seaweed cultivation is also known as marine macroalgae cultivation. It can store CO2 dissolved in seawater. Seaweed incorporates the products of photosynthesis into its tissues as it grows, locking carbon away from the surrounding water and atmosphere. Equilibrium is achieved at the ocean's surface where carbon dioxide moves between the air and water. Seaweed alters the balance of CO2, causing gas to shift from the atmosphere to ocean for a re-establishment of the equilibrium. Fast-growing seaweeds can draw substantial amounts of carbon dioxide out of the atmosphere. The key to curbing climate change is to ensure the carbon trapped in seaweed doesn't return to the atmosphere. This can happen when seaweed dies and decomposes in shallow water. Researchers endeavor to cultivate strains of kelp, which is brown seaweed, in an effort to mitigate climate change and sustainability. A major benefit of kelp is that it can feed humans, livestock, and it requires only sunlight, while the nutrients to grow are readily available in seawater. Artificial upwelling is pumping up cooler, nutrient-rich waters from the deep to stimulate phytoplankton activity and draw down carbon dioxide. Natural upwelling is caused by winds and the rotation of the earth, which can intermingle the generally colder, deeper water with water in upper ocean layers. Deep ocean water is often rich in nutrients and can therefore increase primary production in the upper sunlit ocean layers. Artificial upwelling has many adverse environmental effects. It is worth noting that any enhanced biological production at climate change mitigation scale is likely to deplete mid-water oxygen levels. The ocean's thermocline is disturbed, and on centennial timescales, it may result in a high global mean temperature. Artificial downwelling, on the other hand, is the downward transfer of surface water and carbon to the cold, deep ocean. As the warmer surface water cools down, it takes up more carbon dioxide via a process known as cooling enhanced solubility. There are four categories of artificial downwelling technologies: wind powered pumps, density current generators, current induced artificial downwelling, and wave powered pumps. Ocean fertilization is a form of geoengineering that involves adding nutrients to the upper sunlit layers of the ocean to stimulate phytoplankton activity. In the deep ocean, the dead phytoplankton can be broken down by bacteria or can settle on the seafloor and be buried. Many adverse effects are attributed to ocean fertilization. Toxic species of diatoms have been observed during mesoscale iron fertilization experiments. The experiments demonstrate that iron fertilization could increase biomass of diatom species from the genus Pseudonychia, which produces domoic acid, a neurotoxin capable of causing significant harm to marine ecosystems. Also, potent greenhouse gases such as methane and nitrous oxide are produced during the subsurface decomposition of phytoplankton. Alkalinity enhancement occurs through the weathering process. It is a natural process by which silicate and carbonate rocks break down. Ocean alkalinity enhancement aims to increase the alkalinity of the oceans by adding calcium carbonate to the ocean from limestone rocks or by using electrochemistry. Numerous paths to enhance the alkalinity of the ocean exist. By boosting the alkalinity, it could help to 1. Increase the ocean's carbon dioxide uptake, 2. Counter seaweed acidity, 3. Provide a large and stable storage medium for anthropogenic carbon dioxide, and 4. Raise the carbonate saturation state of the oceans, reversing the effects of ocean acidification. This is a depiction of how alkalinity carbon dioxide removal works. Electrochemical CO2 removal uses electricity to rearrange water and salt molecules in seawater into an acidic and basic solution. Negative impacts to the ocean ecosystem and environmental impacts would ensue due to the industrial inputs and outputs of an electrochemical facility. As with existing power and desalination plants, seawater intakes can pose a risk to many marine organisms. Electrochemical CDR techniques would also cause local pH and chemical equilibrium changes to seawater, which would affect marine life and ecology depending on rates, magnitudes, areas, and time scales of change. Stratospheric aerosol injection is the reduction of atmospheric temperatures by injecting a reflective aerosol into the lower stratosphere. Unfortunately, there are dangers associated with stratospheric aerosol injection. This approach may reduce rainfall in some areas of the world. Loss of crops and access to fresh water due to reduced rainfall could lead to starvation and suffering. If this approach were used, it would be important to develop and implement measures to protect people and save lives and livelihoods. Despite the potential problems with this method, the benefits could exponentially outweigh its downsides. Marine cloud brightening is the whitening of clouds on land or seeding clouds above the ocean to increase planetary albedo. Research like stratospheric aerosol injection research has solely consisted of computer simulations and observations of naturally occurring phenomena. The general idea behind marine cloud brightening is to seed stratocumulus clouds with small seawater particles to enhance the cloud's albedo. Marine cloud brightening has low technological readiness due to the historical lack of success associated with cloud seeding. Serious cloud thinning is the general decrease of the resistance to the escape of infrared radiation from the Earth by thinning cirrus clouds. It is still theoretical, as most research is being conducted via computer simulations. Cirrus clouds trap heat and have a net warming effect compared with normal clouds. Cirrus clouds can be thinned by seeding them with aerosols that will stimulate ice formation, causing the cloud's ability to trap heat to be diminished. Surface albedo modifications involves strategies to increase the reflectivity of Earth's surface. Surface albedo modification is the simplest and most technologically ready of the selected solar geoengineering technologies. International ocean law governance is comprised of a patchwork of global framework agreements, sectoral agreements, and customary international law rules. The planet is on a pathway to a temperature increase of approximately 3.2 degrees Celsius by 2100, far beyond a safe level. The United Nations Convention on the Law of the Sea established a comprehensive international legal framework to govern activities related to the global oceans. UNCLOS remains one of the widely adopted international instruments, and it plays a crucial role in governing marine geoengineering activities. UNCLOS and the 1994 agreement signed on July 29, 1994 are extensive, complex documents touching on a wide range of ocean policy issues and U.S. interests. President Clinton, the 42nd U.S. President, formally submitted UNCLOS, its annexes, and the 1994 agreement as a package to Senate. UNCLOS addresses naval power, maritime commerce, coastal state interests, marine environment protection, marine scientific research, and international dispute settlement. Some members of the executive branch have stated that some, but not all, portions of UNCLOS reflect customary international law. The objective of the United Nations Framework Convention on Climate Change, also known as UNFCCC, is to stabilize atmospheric greenhouse gas concentrations. In December 1997, the Kyoto Protocol was adopted to boost the effectiveness of the 1992 UNFCCC. The protocol committed industrialized countries and countries in transition to a market economy that would achieve quantified emissions reduction targets. The Paris Agreement aims to strengthen the objectives of the UNFCCC by holding the increase in global average temperature to well below 2 degrees Celsius. The preamble states that it recognizes the parties may be affected by climate change as well as the impacts of the measure taken to mitigate climate change. Duly noted is the importance of ensuring the integrity of all ecosystems, including oceans, and the protection of biodiversity. Secondly, emphasis is placed on the intrinsic relationship that climate change actions, responses, and impacts have with equitable access to sustainable development and eradication of poverty. UNEA, the United Nations Environment Assembly, contributes immensely to global environmental governance and has been referred to as the world's parliament on the environment. The mandates of UNEA are threefold. First is to review and identify emerging environmental issues with international significance. The second is to promote international cooperation. The third mandate is to stimulate environmental cooperation. The 1972 Convention on the Prevention of Marine Pollution by Dumping of Wastes and Other Matter is also known as the London Convention. An amendment to the London Protocol prohibits ocean iron fertilization, except for activities that qualify as legitimate scientific research. Ocean fertilization is defined as any activity undertaken by humans with the principal intention of stimulating primary productivity in the oceans. The assessment framework for scientific research involving ocean fertilization as of 2010 can be seen below. The CBD defines biological diversity as the variability among living organisms from all sources, including terrestrial, marine, and other aquatic systems, and the ecological complexes of which they are a part. The Antarctic Treaty was signed in Washington on the 1st of December 1959. It entered into force in 1961. The US and Russia maintain a basis of claim in regard to territories. The primary purpose of the Antarctic Treaty is to ensure, in the interest of all mankind, that Antarctica shall continue forever to be used exclusively for peaceful purposes and shall not become the scene or object of international discord. The Scientific Committee on Antarctic Research, SCAR, is an observer at the Antarctic Treaty Consultative Meetings, ATCM, and there is a meeting of the Committee for Environmental Protection, CEP, at each ATCM where SCAR provides independent and objective advice in a variety of fields, particularly on environmental and conservation. The global and regional governance regimes on marine geoengineering are gradually taking shape. Various legislation, such as the Kyoto, London, and Madrid protocols, are considerable progress in ensuring a robust regulation of marine geoengineering activities. Similarly, the cooperation of international multilateral agreements that were previously discussed in developing a robust governance framework for CDR and SRM technologies is relevant. Some form of CDR or SRM is of most importance if the world is to stay within 2 degrees Celsius of warming. There is still a world of information to unearth about climate change and the impacts of CDR and SRM. The knowledge gap is apparent and reflected in the complexity of the climate system and its interactions with other systems. The difficulty of developing climate models that adequately represent what is predictable and what is not is a major learning curve in the strategies employed. In the realm of climate engineering, ambiguity is a common concept. There are different interpretations of the same scientific evidence as well as different views on matters of justice, equity, and fairness.